let's start talking about SAT prep. And like I said, I'm not going to go over every single problem, just a few of them. Like the first problem here. Now, this is something that we know. We know that x squared is equal to 0.01. And now I have x to the negative fourth power. Now, if you see a problem like this with exponents, this is where you're going to use exponent rules to rewrite an exponent. Because what we want is x to the negative fourth to be something that has to do with x squared. So we're going to have to figure out what is happening to x squared since we know what the value of x squared is. Now, with a negative exponent, how do I rewrite? If I have x to the negative fourth, what is that really equal to? What does that negative do? That negative exponent? It turns into 1 over x to the negative fourth. It's that rule, x to the negative a is equal to 1 over x to the a power. Now, if I look at x to the fourth, how can I rewrite this as something with x squared? Well, what's happening to the 2? No, how do I get the 2 to a 4? Yeah, x squared squared, right? So this is really 1 over x squared squared. Now, do I know what x squared is? Yeah, it's 0.01 squared. Because the first thing we did here was we took care of the negative exponent, made it into 1 over x to the fourth. And then x to the fourth is really x squared squared. So you got to know your exponent rules in this case. And that's what's happening here, is manipulating your rules. So now I need 0.01 times 0.01. But 0.01 is really what fraction? Is this what? Yeah, it's 1 over 100. So this is going to be 1 over 100 quantity squared. So what's 100 times 100? Which is equal to 1 over 1 over 10,000. Now, I guarantee you're going to get a problem where you're going to have to manipulate an exponent like this. And since you're given this, this is something that you're not going to touch. You're going to want to make this x to the negative fourth power into something with an x squared. Because that's the only number you know. So whenever you know something with that number, you want to transform this into that power. So this is using a lot of those different properties. So you got to know your exponent properties, which you've had in Algebra 1 and we've covered again in Algebra 2. Now, this third one, it says, what's the product of the two solutions? Now, you're going to find out there are a lot of problems. Like, for example, number 2, which is up here, it says, all right, two binomials multiplied together is equal to ax squared plus bx plus c, which is expected when you multiply two binomials like that. But then, once you figure out what A and B is, it doesn't just say what's A and what's B, it's what's A minus B. So you have to take that extra second step. So you got to read this carefully and figure out exactly what they want. So let's just start with the second one. If I multiply these out, I don't care how you multiply them out. You can FOIL them, you can do whatever you want. 3x plus 2y, or plus 2, 5x plus 1, that's 15x squared plus 10x, that's 3x plus 2. So this is going to be equal to 15x squared plus 13x plus 2. What's my A value? 15. The A value is the number in front of the x squared. What's my B value? It's my 13. Now what do I want to do with A and B? Subtract. What's 15 minus 13? 2. So we ended up with 15 minus 13, which is 2. Now, I've seen in every practice test that you've taken so far, with every single practice test you've taken so far, you have found an A, or you have found like A, B, and C, and then you had to either multiply them, add them, subtract them, that type of a thing. So it's not just finding A, it's not just finding B, it's not just finding C, it's finding that and then doing something with those answers. So do I look like I want a cookie?
Not really.
Alright, so this theme pops up here again. It says, alright, you got to solve this equation, which is what would be a normal problem. But then it says, take the solutions and then multiply them together. So how many solutions should you get? Probably 2. So take the 4n times n plus 8 equals 36. Multiply this out. What's 4n times n? 4n squared plus, what's 4n times 8? 32n. And that's equal to 36. But if we subtract it from both sides, we'd end up with this. Do you agree with that? That if we subtracted 36 from both sides, it'd just be 4n squared plus 32n minus 36 equals 0?
What do you mean both sides?
Take 36, subtract 36 from the right, subtract 36 from the left to get it equal to 0. Because we want to get it into ax squared plus bx plus c equals 0 form. Now, how do you solve that? First, you got to factor, then set each factor equal to 0. Now, when we're factoring, is there a common factor between the 4, the 32, and the 36? Is there a number that can divide into 4, into 32, and 36? What's the number? 4. Divide that by 4, divide that by 4, divide that by 4, divide that by 4. Is that a legitimate thing to do? Absolutely. What's 4 divided by 4? 1. So I got n squared. What's 32 divided by 4? 8. So it's plus 8n. What's 36 divided by 4? So it's minus 9 is equal to 0. Now, do I know two numbers that multiply to get the middle term, which is 8, or to get the last term, excuse me, which is negative 9, that when I add them, I get an 8? So, when I'm multiplying, I need positive times negative. Negative 1 and 9. Because if I go negative 1 plus 9, I get an 8. So it's n plus 9, n minus 1 is equal to 0. So we're able to factor that. Set those equal to 0. What's n plus 9 equal to 0? What's my n? Negative 9. N minus 1 is equal to 0. What's my n? Positive 1. But it says, what's the product of the two solutions? What are my two solutions? Negative 9 and 1. So therefore my product is equal to negative 9 times 1, which is negative 9. This is a theme that has shown up a lot in these problems, where you have to do all this factoring and you have to do all this work, and then all of a sudden you have to do something extra. You have to multiply a couple numbers together, or subtract a couple numbers together, or do that. So make sure that you're reading the questions, because I guarantee you that they're going to have some answers that are going to throw you off on there. Yeah. Basically, I subtracted 36 from both sides to get it equal to 0. Because if it's quadratic, the only way to solve a quadratic function that we know of is to get it equal to 0. So since it was equal to 36, that's not helping us. We got to get the 36 out of there, so it's a 0. So that's what we want to do. We want to solve ax squared plus bx plus c equals 0. Divide out common factors when you can. That makes sense? All right. Now, arc length. Arc length is tied to circumference of a circle. So basically, it's saying that for 30 degrees, when radius is 6, that's the length that we're looking at. Well, that would be the circumference of the entire thing. How many degrees are there? 360 degrees at our total. Now, how much does 30 take up of 360? Take 30 divided by 360, and that tells you how much. 1 over 12. So that's 1 over 12. So this is 1/12 of the entire circle, the length of the circle. So x is going to be equal to 1/12 times the entire circumference. Which would be 1/12 times 2 times pi times 6. Absolutely 100% correct. Now, what's 2 times 6? 12. Don't the 12s divide out? So if that's 12, divide by 12, what are we left with? Pi. We like pi. That's a joke. So when you're talking about arc length, you're talking about the circumference, the length of the circle. And you can kind of tell from this. And I want to jump to the sector question. So that's on the 3rd page. The answer is just pi. if you looked at the sector is talking about a piece of pie. If you think of a sector, you're talking about a piece of the pie, which would be this. That's 60, but we're talking about the whole thing. Now, do we know what the radius is? We don't know what the radius is, but we know what the area is. It says the area is equal to the area of the sector is equal to 24 pi. Now, again, ask yourself is how much is the sector of the whole circle? How big is the piece of pie? It says 60 degrees. Well, how big is a circle? 360 degrees. So this is going to be 60 degrees out of 360 degrees, which is 1 over 6. So I want 1/6 of the total area. So 1/6 of pi r squared is equal to how much? What's the area of the piece of pie that we took out? 24 pi. So the pi's divide out, multiply by 6. 6 times 4 is what? 24. So carry the 2. 6 times 2 is 12. Carry the 2 is 144. That's got to be equal to r squared. They rigged the problem for us. So what's r? R has to be 12. Now, both of these problems, one over 6 times 6 is 1. Yeah, so that's gone. So I'm just left with r squared. Equals the 144. Now, the thing is, you have to remember a sector is going to be like a piece of the pie. So we're going to use the area equation, pi r squared. An arc length is just like the arc length is going to be the length on the circle, so we're dealing with perimeter, or circumference in that case. So there's a chance you'll see some sector work on there, and the formula sheet that I've seen doesn't have a whole lot with that. The nice thing is your formula sheet's going to have areas of triangles. It's going to have the special right triangles, 1, 2, and 3, 1, 1, square root of 2, that type of thing. But it doesn't have anything to do with sector work. If you think of here, area is going to be sector. Circumference is going to be arc length. If you want to think of it like that. And also, another way that you can think about it is, well, arc length is first in the alphabet, circumference C is first in the alphabet. So they're tied together. Sectors, well, actually, no, that's not even true. Arc has a C, well, that's not even true either. You just got to remember that arc length has to do with circumference. All right, just remember that. You guys remember so many weird things. You guys can remember a couple of those things. I tried to do something nice. Didn't quite happen. Now, this falls under the whole super typical story problem that has a linear system in it. If you let x be equal to the students, y be equal to the non-students, how many people participated? There were 10 participants. So x plus y is equal to 10. Now, if x is the students, how much money did the students get? $15. How much did a non-student get? 10y, and that's equal to 120. Now it says, how many students do we want? So I want x, I want my y's. So what am I going to eliminate? Yeah, so I'm going to multiply the top by negative 15. So I'll get negative 15x minus 15y is equal to negative 150. And in the bottom, 15x plus 10y is equal to 120. Negative 15 plus 15 is how much? 0. Negative 15 plus 10 is negative 5y. Negative 15 plus 110 is negative 30, since we're just adding. Divide by negative 5. How many non-students are there? 6. There's your answer. Okay, well, that's non-students. So if I know x plus y is equal to 10, so x plus 6 has to be equal to 10. So x is equal to 4, so there's 4 students total. That's probably what you should have done. You would have got it a lot faster than I did. So 4 students, 6 non-students. Couple of these we'll do on Monday when we come back, because I got some last minute stuff to do. We'll go with one more today. This guy right here. If 5 is x minus 5 to the x minus 4 is equal to 25 to the x plus 3, what do you think the key is here? Not in this case the exponents. It's the base. Is there a relationship between 5 and 25? What's the relationship? 25 is 5 what? 5 squared. So I can rewrite this as 5 squared to the x plus 3 power. That's equal to 5 to the x plus minus 4 power. Now when you have a power raised to a power, what do you do with those powers? Multiply them. So you're going to want to multiply those. So let me move this over. We got 5 to the x minus 4. We're going to multiply the powers, so we get 5 to the, what's 2 times x? 2x. 2 times 3 is 6. Now, if the bases are the same, the powers have to be the same. So I could say x minus 4 is equal to 2x plus 6. And that's the whole thing here, is that you want to get the bases to be the same so we can just set the exponents equal to each other. Subtract an x. Negative 4 is equal to x plus 6. Subtract a 6. X is equal to negative 10. And if you dump it back in here, you get negative 10 minus 4 is a negative 14. You get 2 times negative 10 plus 6. That's negative 20 plus 6, which is negative 14. So it ends up being 5 to the negative 14 is equal to 5 to the negative 14. All right, we'll do one last one. Absolutely. Now, like I said, when I did this problem, at first I was trying to be all fancy because not that I'm fancy, it's just that I am used to doing algebra work. But we don't know anything about what's in the bubbles. All we know is what's going on here and what's going on here. Well, what do you do? What happens when you add these two numbers together? 2 plus a negative 6. Negative 4. What's 8 plus negative 12? Negative 4. So that's the pattern that jumped out at me when I got stuck with everything. Well, 3 plus 12 should equal x plus 4x. So if I add these two things together, and I just see the pattern just kind of jumped at me. And what's 3 plus 12? 15. What's 1x plus 4x's? 5x's. So divide by 5, x equals 3. And this idea is looking for a pattern. And that's where I'm saying, all right, they gave you a rule, but there's nothing to help you with that rule. But look at the numbers that are common in both sides. Maybe there's a pattern that's going on here. Well, when we add these two, you get the same thing. You add these two, you get the same thing. You add these two, you get the same thing. You add those two, you should get the same thing. So that's a nice little pattern. And since I'm on the last page, does that make sense?
Yeah, but was there any way you could have figured that out with trying to do the circles?
Not that wouldn't have taken you a long time to do.
We were just looking for the x.
Yep, that's it. What's the value of x? X is 3. Now, this last one, and so I'm just doing this because it's the last one. If x equals 3, what can't be a value? So plug in 3. So 6 plus y has to be greater than 15. Subtract 6. So y has to be greater than 9. So which one can't work? 9. Not too bad.